All right. Uh, Section 5.1 is about proportional reasoning. And what that means is we're going to be doing proportions today. Just as a reminder, it may have been a while. Proportions involve two ratios that are set equal to each other. And the approach that we're going to use to solve for a variable that's in a proportion is called cross multiplication, cross multiplying. And once you see it, my guess is a light bulb will come on and you go, oh, yeah, I remember that. If not, and you have questions, of course, you can ask those. It's possible that you kind of look at these like, oh, yeah, that's simple. I got this. And that may be true for the most part, but there may be some challenging questions. And when you set up your proportion, you want to make sure to do it in a way that makes sense based on the problem you've been given. Just sort of a basic, straightforward proportion is something like 2 over 9 is equal to x over 15. And essentially what we're trying to figure out here is what would x have to be for this fraction over here to have the same value as this fraction over here. And so we want those two to be equal to each other. We've got to figure out what x is going to be. Here we're told to round our answer to the nearest hundredth. So we'll do a little rounding today. And you know, rounding is something that you can take for granted too. So we'll talk about that and be patient as we go through it. I mentioned cross multiplying, and cross multiplying is a technique that's used for proportions. And what we're going to do is we're going to multiply this way, x times 9, which you could write it as x times 9, but instead of that, we're going to go ahead and write it as 9 times x. Put the number first and the variable afterwards. They're multiplied together. We don't need a symbol in between those. And then go in the other direction, 2 times 15, that's just 30. And so now what we have is 9 times x equals 30. We won't do a ton of algebra in this class, but it will come up from time to time. And here, this says 9 multiplied by x. If I want to make multiplying go away, what do I need to do to get rid of that 9 so that I have x by itself? Very good. Summer, Brianna, you're exactly right. We're going to divide. And what we're going to do is we're going to divide by 9 so that these cancel. And if we divide the left by 9, we also have to divide the right by 9. On the left, all we have left is the x that we were trying to solve for. On the right, we have 30 divided by 9, which is 3.33333. And that keeps going. In this one, we were told to round to the nearest hundredth. So the first thing we'll have to do is find the hundredths place. That's 2 places past the decimal. And then in order to round this, we're either going to round it down to 3.33 or round it up to 3.34. Those are the only 2 possible answers here. Once we get to this point and we're going to round, we're either rounding down to 3.33 or up to 3.34. And the way we decide is we look one space to the right of that number. If that's 5 or bigger, we round up. If it's 4 or lower, we round down. Here's a 3, so it's 4 or lower. So we're going to round this down to 3.33. So if I wanted a fraction that was equivalent to 2/9 that had 15 in the denominator, the numerator would need to be 3.33. Let me know if you have any questions about anything we did in there. We'll talk a lot about proportions today, but we're going to try just sort of a real world situation first. A store sells laundry detergent in a small 36-ounce bottle for $2.99 and a large 48-ounce bottle for $3.79. Which is the better buy? I'm going to set up a poll for this, and you can solve this any way you want, but which is the better buy? And what I mean by that is the small bottle, the large bottle, and you're going to see this in the poll. The small bottle, the large bottle, they're the same, or I have no idea, I can't figure it out. I don't have enough information to solve this. That's what you're going to see in the poll. And I realize that, if you only have $3 in your pocket, you're kind of stuck with one, but that's not what this question is about. This question is about which one is the better value, which one is you know, gives you the most detergent for your money. And we didn't talk about a way for you to approach this. I'm actually going to talk about a couple of different ways, and then you can tell me if you did something different than whatever it is that I bring up. Let's go another 20 seconds on this one, and then we'll talk through it together. And if you need more time, just let me know. That's totally fine. You can just tell me. All right, let's see how we did on this one. Okay. Not unanimous, strong agreement, and interestingly, spread around over all the possible choices. That makes this one really interesting to me. Okay, so I think what the most common approach here, what most of you probably did, and if you did this a different way, that's okay. But I think what's most common here is to look for the unit price. In other words, what is the price per ounce? And in order to find that, well, I'm paying $2.99 for 36 ounces, so I'll just divide $2.99 divided by 36 ounces. And then what I'm paying is, let's see, $2.99 divided by 36 is 0.0830. That's probably far enough. I could keep more decimals if I wanted to, but so I'm paying about, based on looking at this, I'm paying about 8 cents per ounce. So for every ounce, I'm paying 8 cents. All right, then we go over here to the other one and say, okay, for that one, I'm paying $3.79 for 48 ounces. So how much am I paying per ounce? And we'll divide $3.79 divided by 48, and that's 0.078789. And that keeps going also. Well, this one is a little more than 8 cents per ounce. This one's a little less than 8 cents per ounce. So the better buy is the 48-ounce bottle. The large bottle is the better buy. I'm getting more for my money because I'm paying less than 8 cents an ounce instead of more than 8 cents an ounce. They're awfully close. There's reasons you might buy the smaller bottle. Maybe you don't have room to store the large one. Maybe, like I said earlier, you only have $3, but that's our approach here. If you did it upside down from this and said, I'm going to figure out how many ounces I get for every dollar, that's absolutely fine. That makes perfect sense, and you'd get the same result. If you did, how many ounces am I going to get for $1? We divide it that way and find that the large bottle is the better buy. Let me know if you have questions on that. We're going to spend a little more time on this question. So instead of what we just did there to kind of find the unit price, we could also use a proportion for this. And here's how we might do that. And some of you may have done this, and if you did, I think that's great. I wouldn't have thought of it, but it's a really cool way of going about this problem. You could say, okay, well, this is $2.99 for 36 ounces. If I was paying the same rate, then what would I have to pay for 48 ounces? And so what this is going to tell me is whatever this price is, I'm going to get a number over here that's going to be the same price for my 48 ounces. This would make them, if they were the same as far as value is concerned, that's what this number is going to tell me. When I get that, I'm going to compare it to $3.79, and then I'll know, hey, wait a minute, that $3.79 is a really good price. or no, that's 379 is a bad price. So we'll solve this proportion by cross multiplying. 36x is whatever 299 times 48 is, 143.52. Oops. Just like we did before, we're going to divide both sides, and we're going to divide by whatever that coefficient is. We're going to divide by 36 on both sides. Those cancel, leaving x equals, and we'll divide by 36, 398. And that keeps going. So actually, if I rounded to the nearest hundredth, it would be 399. And so if I was going to pay the same price per ounce that I'm paying for the small bottle, the large bottle would cost 399. Well, since it's 379, that makes the large bottle the better buy. I think that's a really clever way to go about this. Some of you may have done it, and if you did, that's really great. But that's a way for us to use a proportion. We could also do this one by sort of estimating. Same setup. And okay, I'm paying $2.99 for a 36-ounce bottle. Well, what if I just want to ballpark this? I don't need an exact number. I'm just going to ballpark it. And that $2.99 is awfully close to $3. So I'm going to say it's $3 for 36 ounces. Well, at this rate then, how much would it be for 48 ounces? And here you have to kind of lean back on your knowledge of fractions from Math 122 and say, hey, well, this fraction, that's equivalent to 1/12. What would I have to do over here to make this equal to 1/12? What number would go in that numerator over there to make that one 1/12? To give that one the value of 1/12, what would have to go right here? Very good, Shelby, Jennifer, you're exactly right. I would need a 4 here. And so basically, if I say that this $2.99 is really kind of $3 for 36 ounces, then at the same rate, I'd be paying $4 for 48 ounces, which here again makes that a good price, and it makes the large bottle a better buy. One of the things we saw at the beginning of last semester, excuse me for a minute. Okay, one of the things we saw at the beginning of last semester is there can be more than one way to solve a problem. And that's okay, as long as the way you use is valid and reliable and you can use it over and over again. The same thing's true this semester. Maybe there's more than one way to solve a problem. And here we saw 3 different ways to answer this question, and any of them would be just fine. Anybody have questions on our laundry detergent setup? Okay, very good. It's been estimated that every 2,000 pounds of paper that is recycled saves about 16 trees. If a college recycled 8,000 pounds of paper during a semester, how many trees did it save? And this is a straightforward proportion question. The key is we have to make sure that when we set up our proportion to solve this, we do so in a logical manner. What I mean by that is this. If I want to set up a fraction over here that's 2,000 pounds on top and 16 trees on the bottom, that's great. Now what I'm going to do then is over here, my 8,000 pounds, I put pounds on the top in this fraction, so I need to make sure I put my 8,000 pounds on the top of that fraction. And then the trees, how many trees did it save? We could just call that X. That goes in the denominator. If you wanted to set this up with trees on top and pounds on the bottom, you could. Just make sure you do that with both fractions. If you put trees on top in this fraction, then you also have to put trees on top in this fraction. My guess is you won't have trouble solving once you get your proportion set up, but you want to make sure you're careful when you do set them up. So we'll go ahead and finish this one up then. 8,000 times 16 is 128,000. Go in the other direction, that's 2,000 times X. The variable can be on the right. That's totally fine. There's no rule that says it has to be on the left. But just like we've done before, to get rid of that multiply by 2,000, we're going to divide by 2,000 on both sides. These will cancel, leaving x. And we'll have 128,000 divided by 2,000. And it looks like they saved, how many trees did they save? 64. Let me know if you have questions about that before I have you try one. Fantastic. Here goes. Similar idea. 2,000 pounds of paper saves about 16 trees. If a college recycled 13,250 pounds of paper, how many trees did it save? Round to the nearest whole number. So make sure you go to the whole number. I'm going to set up a poll for this one just to make sure we're doing okay with our proportions. This is definitely the type of question you could expect to see in homework practice, on a quiz, on an exam. So let's make sure that we're comfortable with this before we go forward. And we don't have to be in a hurry today. The proportions topic is relatively short. So I want to make sure everybody has a chance to try this out. I'm thinking we'll go another 20 seconds, and then we'll talk about it together. Okay, gotcha, Brianna. And let's go ahead and take a look and see how we did on this one. Unanimous. That's good news. Sometimes the poll itself, gets obscured or covered up or off the edge of the screen somehow. So that does happen from time to time. Not very often, but if it does, it's perfectly fine. Just kind of type it in there. Okay, so let's take a look at this one then. So we're told that 2,000 pounds, 16 trees. So I'm going to do 2,000 over 16. I put my pounds on top and my trees on the bottom, so I want to make sure to do the same thing with the other one. 13,250, which means trees go on the bottom, and that's what I'm trying to find. We'll cross multiply here. 16 times 13,250 is 212,000. And that's 2,000 times x. Getting that x by itself, we'll divide both sides by 2,000. Those will cancel, leaving us x. And on the other side, 212,000 divided by 2,000, 106. We're told to round to the nearest whole number. This answer already is a whole number, so we don't need to round anything at all. We're good with just the 106. That went really great. I feel really good about where you are with proportions, but we're going to practice a whole bunch more of them today. Here's one that's a little bit different. Excuse me. A 3-foot tall dog casts a shadow that's 8 feet long. At the same time, a tree casts a 30-foot long shadow. how tall is the tree? And I am going to set up a poll and allow you to try this one, but I want to kind of give you a hint or a push in the right direction. If we can, it really helps to have a picture. And so here we're going to draw a picture, and it doesn't have to be a work of art. Here's my 3 foot tall dog, and it has a shadow that's 8 feet long. And then to go along with this, I have a tree that I don't know how tall it is, but its shadow is 30 feet long. It's something we're going to talk about later on in the course, but the reason that we're doing this at the same time is that means that the sun is at the same angle over here. And so what we've created are triangles that have the same shape. And when we have similar triangles, we can use a proportion to answer questions. We just have to make sure we're using corresponding sides. What we're trying to find out here is how tall is this tree? I'm going to let you solve this by setting up a proportion, and I'm going to set up a poll for you. The instructions there, it says hundredth in parentheses. That means we're going to round our answer to the nearest hundredth, but you can see that over there in the choices. And units aren't really a part of our answer here, but we know it's feet because everything we were given was measured in feet. So the answer that we're giving here is also measured in feet. One thing I do want to say about polling, those of you that had me for 122 are used to this, and it's normal, and it's sort of a typical thing to do in class. Polling may be relatively new for you, and that's okay. Essentially what this is it's a chance for you to practice the type of problems that you'll see in homework, on quizzes, on exams, and kind of see how you're doing. And equally as important, this gives me a chance to see how you're doing as a class on any one topic. Do I need to spend more time on this, or are we in really good shape and we can keep on going? The polling has a lot of value going both directions. You get to see how you're doing, and also I get to see how you're doing. And so it's something we'll do quite a bit of in most of our class sessions. Something else I want to point out, though, is if you get an answer and it's not one of the ones that are shown, pick the one that's closest to yours, because that lets me know that you had enough time to finish. And, it's possible I maybe made a mistake when I typed them up and your answer is the right one. But even if your answer isn't the right one, if you pick the one that's closest to yours, then when we go through the explanation, you can ask questions about whatever you have questions about. So, I'd rather have you just sort of pick the one that's closest to yours than not respond at all, because I'm trying to gauge how long you have to work on it. I think we'll go another 20 seconds on this one and then talk through it together. All right, let's see how we did. Okay, not unanimous, but strong agreement. That's usually where we land, and that's perfectly fine. If you see something in this explanation that you're not sure of, don't hesitate to ask. Um, that's what we're here for. If everybody already knew how to do everything, then we wouldn't have to fool with it at all. But it's absolutely fine for you to ask questions, and I encourage you to ask questions. All right, so 3 foot tall dog casts a shadow that's 8 feet long. So you could put the 3 foot dog over the 8 foot shadow. And then at the same time, the tree that I don't know how tall it is casts a 30-foot shadow. A key here is I put my 8 feet long shadow on the bottom. So I also need to put my 30-foot long shadow on the bottom. And then I'm trying to find out the height of the tree. Most of you probably did it that way, just to show you that you could do it the other way if you wanted to. I'm going to say, all right, I've got an 8-foot long shadow I'm going to put on top, and my 3-foot tall dog, the height of the dog, I'm going to put on the bottom. This time I put the shadow on top and the height of the dog on the bottom. So I'm going to put the shadow of the tree on top and the height of the tree on the bottom. It's going to work either way. Most of you probably did this just because that's the order they were given to you in the problem. That's completely fine. It's what I would expect. But I do want you to see that if you did it the other way, that's okay, as long as you're consistent. If you put height of the dog, you need height of the tree. Shadow, shadow. Similarly, over here, I put shadow, shadow, height of the dog, height of the tree. So I just need to be consistent when I decide to make my proportion. We cross multiply here. 30 times 3 is 90. 8 times x is 8x. And then to get that x by itself, we'll divide both sides by 8. Those cancel, leaving just the x. And on the other side, I've got 90 divided by 8 is 11.25. I was supposed to round to the nearest hundredth. This already is. So we're all done there at 11.25. Let me know if you have any questions about what we did there. Fantastic. Polls have been really good today, so I feel good about where you are. Now let's talk about speed. It took Renee 24 minutes to go 15 miles. What was her speed in miles per hour? So 24 minutes to go 15 miles. We want to know miles per hour. At first glance, you might not think proportion here, but, well, wait a minute there. 24 minutes to go 15 miles. Then I want to know what was her speed in miles per hour. So really what I want to find out is how many miles did she go in 1 hour? Do I want to put a 1 up here for hours? Very good. Jennifer, Summer, Jalen, outstanding. You're exactly right. We don't want to put a 1 up here because it's 1 hour. We do want it to have the same value as 1 hour, but we need our units to be the same as they are over here. And since that's in minutes, we're going to put 60 over here, 60 minutes. So essentially now what we're saying is, okay, if she went 24, if it took 24 minutes to go 15 miles, how many miles in 1 hour? But we want to make sure we use 60 minutes. And now we're in great shape. Now we can cross multiply. 60 times 15 is 900. That's 24 times x. We'll divide both sides by 24. These cancel, and we'll have 900 divided by 24 is 37.5. And that's going to be her speed in miles per hour. So if you're going 15 miles in 24 minutes, then you're going 37.5 miles per hour. Are there any questions on that before I have you try one? And great job, those of you that caught on to the 60 minutes right away. That's excellent. Okay, you travel 18 miles in 34 minutes. What's your speed in miles per hour? Round to the nearest tenth. I'm going to make a poll for this one. Turns out to be a straightforward proportions problem, but I want to make sure that you're aware of the fact that that 1 hour is going to be 60 minutes. That's sort of the key in there. Go another 15 seconds and then talk about it together. If you need more time, you let me know. All right, let's see how we did on this one. Wow, unanimous. You're doing great on the polls today. I'm really happy. Okay, because over the break, it can be easy to kind of lose some skills, but um, apparently we're in really good shape. So um, 18 miles in 34 minutes, and you might set it up as 18 miles over 34 minutes, and then so how many miles in 60 minutes, because that's an hour. We'll cross multiply. 34 times x is whatever 18 times 60 is. 1080. And we'll divide both sides by 34. Those cancel, and we get that x is 1080 divided by 34, 31.7647, and that keeps going. We haven't done a lot of practice with rounding today, so this one gives us a chance. We're supposed to round to the nearest tenth, so we'll find the tenths place, look one space to the right. Since that's 5 or bigger, we're going to round this up to 31.8. If this position would have been 4 or lower, we would have rounded down to 31.7. Since it was 5 or bigger, we rounded up. Okay, let's look at a map. On a map, 1 inch is 24 miles. If two cities are 2.5 inches apart, how many miles apart are they? And I hope you're kind of seeing here that, boy, there's an awful lot of situations where proportion has value. A proportion is a great way to solve the problem. That's one of the things this section is about, is just looking at a whole bunch of different situations where a proportion is useful. And here, if 1 inch is 24 miles, so 1 inch is 24 miles. If two cities are 2.5 inches apart, how many miles? Make sure you remember, all right, I put my inches on the top and my miles on the bottom, so that's how I want to set up in my other one. Inches on the top and miles on the bottom, and miles is the thing I don't know. Are you allowed to do this with a decimal and turn 2.5 into a decimal and use 2.5? Absolutely. Am I going to do that for this one? No, because I get a chance to review fractions with you, so I'm going to take advantage of that opportunity. If you want to rewrite this as 2.5 to solve it, it's completely fine, and you'll see that in a poll in just a minute. But for this one, we're going to go ahead and use fractions. I'm going to cross multiply 2.5 times 24. And this way, it's just 1 times x. There's not a whole lot going on over there, but what I really want to focus in on is this 2.5 times 24, and it's just a nice chance to kind of refresh your memory about this. I've got this mixed number that I want to rewrite as an improper fraction. And our shortcut there is 2 times 2 is 4, plus 1 makes that 5/2. I want to multiply by 24, so I want to rewrite 24 as a fraction, and that's just 24 over 1. And at this point, I have choices. I could do some canceling, because 2 will go into 24, so I could rewrite that as 1 and 12, but I don't have to do that. Instead, I could just multiply numerators. 5 times 24 is 120. I don't want that equals in there. 5 times 24 is 120 over 2 times 1 is 2, and that's what's equal to my 1x that's over here on the right. Sorry, that's a little clumsy. We went from 2.5 times 24 to 5/2 times 24 to 120 over 2, and this 1 times x is over there. 120 divided by 2 is just 60. 1 times x is just x. And so how many miles apart are they? They're 60 miles apart. Let me know if you have any questions on what we did there. Maybe the fraction reminder was a good thing. Maybe it was terrifying. But it kind of depends. I'm confident that for all of you, it was extremely comfortable. And yeah, of course, that's what you do. All right, let's have you try one. On a map, 3/4 of an inch represents 48 miles. If two cities are 4.5 inches apart on the map, how many miles apart are they? I'll set up a poll for this. If you want to use it, if you want to solve this one using decimals instead of fractions, that's okay. And if you want to try this one with fractions and you get bogged down a little, that's all right. You can be a little rusty with this. And I think doing this one with fractions can be a little clumsy because I think you get some pretty big numbers to deal with. And then I'll let y'all tell me whether you want me to do it with fractions or with decimals when we get to the point where we're going to solve it. We'll do it either way, whatever way you prefer. Let's go another 25 seconds on this one and then talk about it. If you need more time, you just let me know. Let's see how this one went. Okay, strong agreement. Not everybody's in on this one though, so that makes me a little nervous. But of those of you that did it, did really well. So let's take a look. You let me know if you have questions. Oh yeah, so 3/4 of an inch is 48 miles. So the proportion I'm going to set up is 3/4 of an inch is 48 miles. And if they're 4.5 inches apart, how many miles apart are they? So there's my proportion. If you had trouble getting that, you can let me know. It feels a little bit odd to put, a fraction on top of a fraction, but it's fine. There's nothing wrong with doing that. You can have a fraction there. Would you rather see this with decimals or with fractions? I'm happy to do it either way. And this is kind of whoever speaks up, we'll do it the way. Okay, Brian, you got it. Fractions it is. All right. So I'm going to cross multiply here. And I'm going to have 4.5 times 48 is equal to 3/4 times x. So we're going to do a lot of work on the left-hand side of this. The first thing we're going to do is rewrite 4.5 as a mixed number, and that's 2 times 4 plus 1. So 2 times 4 is 8 plus 1. That'll be the same as 9 halves, and that 48 will be 48 over 1. And that's going to equal 3/4 x. I could reduce over here, and this 2 will go into 48, making them 1 and 24, but I don't have to. I can just leave them the way they are and multiply the numerators. 9 times 48 in the numerator is 432. And 2 times 1 is 2 in my denominator. And that's equal to 3/4 x. And at this point, I think I'd probably go ahead and simplify this and do the division. 432 divided by 2 is 216. So now I have 216 is equal to 3/4 times x. Okay, now here, I was kind of hoping you would say fractions because I wanted to get here and I wanted to ask you, I got to get rid of this 3/4. What am I going to do to make this 3/4 go away? What am I going to do to both sides to make that 3/4 go away? Divide. That is true. I'm going to divide by 3/4 on both sides. Of course, one of my favorite lines from last semester, division is the same as multiplying by the reciprocal. So instead of dividing by, hey, sunshine, Jennifer, outstanding. Instead of dividing by 3/4, I'm going to multiply by 4/3. I'm going to multiply by 4/3. On the right-hand side, everything cancels, leaving me just the x, which is perfect. That's what I was trying to get to. On the left-hand side, well, I can just rewrite 216 as a fraction, 216 over 1, and now I can do 4 times 216 is 864. On the bottom, I have 3 times 1, that's 3. And then the last thing I need to do here is divide by 3 to end up with 288. So if 3/4 of an inch is 48 miles, and they're 4.5 inches apart, then they're 288 miles apart. If instead of that you had done 3/4, well, that's just 0.75. And 4.5, that's just 4.5. And you use decimals instead of fractions to set it up, that's totally fine. I enjoyed doing the fraction review, and I really liked getting to say division's the same as multiplying by the reciprocal, and Sunshine and Jennifer getting to say it is fantastic also. So, but if you wanted to do this with decimals, there's nothing wrong with that at all. Any questions on what we did there with that map question or any of the stuff we did with the fractions? Okay. At What's the Matter You, the ratio of males to females is 4:1. If there are 3,000 students, how many are male? Your instinct here might be to go, well, that's 4:1. So 4:1, 3,000 students. I've got males on top, males on top, males on top. What's wrong with this? Why is that not going to work? And you don't have to be elegant in how you would describe it. If it's a little bit, it's not that easy to. Wow, very good, Shelby. Very good, Jennifer. This is fantastic. I love those comments. Yes, you're both exactly right. because this 4-to-1 is the ratio of males to females. So what I'm setting up here is males to females. The 3,000 students, that's the total. That's not the number of females, so it doesn't make sense to put that on the bottom. That's no good. So what I've got to do is sort of back up for a minute, and instead of just charging ahead and making a proportion like I can do in most problems, I need to really think this through for a minute here. So the ratio of males to females is 4-to-1. So I guess because we've been given the total number of students here, the question we want to ask ourselves is, what fraction of the total students are male? And I don't know that that's necessarily an easy question, but given how you've been doing today, I'm thinking you're going to hit this one out of the park too. And we can find it from here. If we know the ratio is 4-to-1, then what fraction of the total students are male? It sure would, Jalen. You're exactly right. Very good. Very good. You're exactly right. If there's 4 males for every 1 female, then that means the fraction of the total students that are male is 4/5. 4 out of every 5 students are male. Now, because we have something that relates males to the total, now we can set up a proportion. And we can say, okay, 4 out of every 5 students are male. So how many male students are there out of the total number of students? But there was a step we had to pause in there and really think through. Wait a minute, I was given males, females. This is total, so I can't use this for my proportion. I need to think this through a little bit and get a ratio that's going to work based on the information I've been given. And now we can solve. X times 5 is 5x. 4 times 3,000 is 12,000. Divide both sides by 5. And there's 2,400 male students. All right. Just sort of a lean back to last semester and the whole idea of problem solving. Problem solving is going to be important for us again this semester, and there's more than one way to do it. And this should have some familiarity to it. A farmer looks out in the yards and sees pigs and chickens. He counts 24 heads and 80 feet. How many pigs? How many chickens? I'll do this one, and then I'm going to have you try one. So 24 heads. So if I want an equation about heads, well, a pig has 1 head and a chicken has 1 head. So adding those together, that's 24 altogether. If I add my pigs and chickens together, I get 24. And then a pig has 4 feet. So 4 times the number of pigs would be feet, plus 2 times the number of chickens, because chickens have 2 feet. That'll give me the number of feet, which is 80. So I have one equation here about heads, one equation here about feet. And then we're going to solve this using algebra. Like I said, we don't do a ton of algebra, but this is a problem that can be done with algebra. Doesn't have to. You can do it with trial and error. You can do it by drawing a picture. But I'm going to go ahead and do it the algebra way. If you want to look at trial and error or doing a picture, we can absolutely do that too. The algebra approach is the one that you might need refreshed on, so that's what we'll do. And it doesn't really matter which one of these you subtract. I'm going to subtract c from both sides. And when I do that, those cancel. And what that leaves me with is that p is equal to 24 minus c. Now that I know that p and 24 minus c are the same, I can take 24 minus c and put it in where the p is. And so I've got 4 times 24 minus c plus 2 times c is 80. And the key here, what we've done, thinking of this from an algebra standpoint, when I started, I had 2 variables, p and c, and 2 equations. That's great. That means I can solve it. But now what I've done is I've turned this into 1 equation with 1 variable. And now I can find out what C is. I can find out how many chickens there are, which is great. So we'll distribute this 4. 4 times 24 is 96. 4 times that negative C is a negative 4C. Plus 2C is 80. I've got like terms here I can combine, negative 4C and 2C. So I can go ahead and combine those, and I'll have 96. See, negative 4 and a positive 2, that's negative 2C is 80. Okay, now a little bit of an algebra reminder. I'm trying to get C by itself, so I need to get the term that has C in it by itself. So as I look at this left-hand side of the equation, I want to peel it from the outside in. So the first thing I want to get rid of is that 96. What am I going to do to get rid of that 96? Subtract minus. You're exactly right, Shelby and Summer. We're going to subtract 96 from both sides. Over here, they're going to cancel, leaving me negative 2C. Over here, I'll have 80 minus 96 is negative 16. And then we've seen this one a lot today. Now we'll divide by negative 2 on both sides. The C is equal to 8. So I just found out that there are 8 chickens. And then if there's 24 animals altogether, could kind of do it in our head. There's 8 chickens, there must be 16 pigs. Are there questions on this before I have you try one like it? And like I said, you don't have to do this with algebra. You can do it with trial and error. You can do it with a picture. But I think algebra was most people's sort of favorite. All right, here goes. Farmer looks out in the yards and sees pigs and chickens. There's 14 heads and 46 feet. How many chickens? I'll set up a poll for this and let you try it. So you could do this with algebra, trial and error. Trial and error would be, well, what if there's 7 chickens and 7 pigs, and see how many feet that gives you. And if it's not enough feet, then you need to add more pigs. If it's too many feet, you need to add more chickens. And doing this with a picture is a really fun way. It would never occur to me in a million years, but it's a really good way. Let's go another 30 seconds on this one, and then we'll talk about it. If you get an answer that's not up there, pick the one that's closest to yours. That way I'll know you've had enough time. All right, let's see how we did here. Unanimous. Not everybody's in on this one, but we were unanimous, so that's a good thing. Um, okay, so farmer looks out in the yard, sees pigs and chickens, 14 heads and 46 feet. So if we're doing this with algebra, our approach is just going to be the same as it was before. Pigs plus chickens makes 14 heads, and then pigs plus chickens makes 46 feet. Last time we did P equals, so this time we'll subtract P from both sides. These cancel, and we'll have C equals 14 minus P. What we're saying there when we say those are equal is that C and 14 minus P are the same. So wherever I have a C, I can put 14 minus P in its place. And so when I rewrite this as 4P plus 2 times 14 minus P, that equals 46. And now I have an equation I can solve. To do that, we're going to distribute the 2 through the parentheses. So we'll have 4P plus 2 times 14, that's 28. 2 times negative P is a negative 2P, and that's 46. We've got like terms here, so I can combine those. 4P and a negative 2P is just 2P plus 28, and that's 46. Like we saw last time, we're trying to get P by itself, so we want to get the term with P by itself. So on the left side of equals, we want to peel it from the outside in, get rid of that 28 first. We'll subtract 28 from both sides. Cancels on this side, leaving us just the 2P. And 46 minus 28 is 18. We'll divide both sides by 2, and P is equal to 9. Wait a minute, 5 was the correct answer here. I got 9. What's going on? Well, what's going on is the question was, how many chickens are there? And what I just found out was how many pigs there are. And so I don't want to answer with 9 because that's how many pigs there are. I want to take one more step and figure out how many chickens there must be. If there's 14 animals altogether and there's 9 pigs, then there must be 5 chickens. Or you can use this equation that you found that the number of chickens is 14 minus the number of pigs. And 14 minus 9, sure enough, would give us 5 for the number of chickens. Let me know if you have any questions on that. Basically, problem solving is going to be something we're going to do all semester long, and so I just kind of want to get you back in the routine of problem solving. All right, a couple of homework notes before we finish up for today. In the practice problems from section 5.1, number 16, you want to make sure your answer is in miles per hour. And these will make more sense once you're actually working on the problems. In number 18, just sort of information, there are 128 ounces in a gallon. That'll be a useful piece of information. Number 23, when it says break even, what that means is $0 total. They didn't win any money. They didn't lose any money. They broke even. They came out at 0. And then in number 31, the project is currently 3/4 done. And in order to finish it, we need to finish the whole thing. So it needs to be 4/4 done.